All right, here's a quick final exam review. A few extra questions that go along with the Chapter 5 test that we'll do. So, some things we covered this semester to be prepared for, things you might want to review. Antiderivatives, we learned that an integral, a indefinite integral like this is an antiderivative. And so we got our power rule. So we're pretty familiar with that, I think. So we're going to add to the power because we're doing the opposite. And we're going to divide by that power, right? And so we've got the 3 is going to hang out. Bump that up to a 5. Antiderivative. All right, so remember the antiderivative sign is negative cosine. So kind of backwards. That's the name anti. And remember with e to the 2x, we're going to need to actually use u substitution for this little bit. Okay, we're really breaking this up into a whole bunch of little integrals. But here we're going to say u is 2x for this little bit right here. If we say u is 2x and du is 2. In other words, we wish there was a 2 in front here. Well, we can put a 2 there as long as we put a 2 over 2. And so what we're really doing is we're really taking this guy here and we're saying we want the integral of 2e to the 2x dx, and we're putting the 1/2 out here, right? And so this now is our u. So it's really e to the u du. And so this is e to the u, and then the 2 and the dx is du. And that's just e to the u. So that all comes out to be 1/2 e to the 2x. Something, as you work with board calculus, that you'll get a little more comfortable with if you're not there. And don't forget your plus c, right? There we have it. All right. Here, this looks a little more complicated. Sometimes if we have a fraction like this, we can actually divide it out. In this case, we can't, but we're looking for a connection. Is there a connection here? And there is. We want u to be x to the 5th minus 3x squared plus 2. That makes du 5x to the 4th minus 6x, and that's it. And that's dx, right? So this is going to be equivalent to 1 over u. So here's our du here. And then we have u on the bottom. So this is equivalent to 1 over u du. And that's easy to do. That's just the natural log of u. And u, we said was, what did we say it was? We said it was x to the 5th minus 3x squared plus 2. And we're going to put that in absolute values there because you can only take the log of a positive number. And this guy here is one that it looks kind of familiar. You might try to take the derivative of this, but you can't. And so this is one of our inverse trig integrals that we need to be familiar with. This 2 seems to be in the way, so let's pull that out. So that's integral of 2 over 1 plus x squared dx, and 1 over 1 plus x squared is arctangent. So this is 2 arctan of x. And that's that. Okay, so arctan, arcsine, be familiar with those there. Okay? Specifically those two. Arc-seeking, you won't see that much. So, all right, so here we've got a curve, y equals x cubed plus 3x squared. We want to use a right Riemann sum with 3 intervals to approximate the shaded area. All right, so I'm going to be expecting a little bit of work on this, but then I'll let the calculator do the job. All right, so we're going to find 3 intervals here. So we're going to break this. This is going to -3 here. You can test it out. -3 is a 0. And so we're going to break this into 3 spaces. And we're going to have one rectangle there. Actually, it looks like we won't need the calculator very much. Looks like we got nice, neat whole numbers. And then we've got a flat rectangle there. So we've got the integral from -3 of x cubed plus 3x squared dx is approximately we need the area of these rectangles. Test it out, plug in -2, and you do get -2, 4, like it looks. Plug in -1, and you will get -1 will give us 2. All right, so those are points there. All right, so our rectangles there, our areas are 1 times 4 plus 1 times 2. So we've got width times height, width times height, width times height. Plus, we should put 0. Actually, I guess it's 1 times a height of 0. Okay, there's our 3 subintervals, and we need to show that. That's good. And we get an area of 6. All right, I'm guessing we're going to get an exact area. We'll find out here. So now using the fundamental theorem of calculus to find the integral from -3 to 0 of x cubed minus 3x squared dx. So we're going to find the antiderivative, x to the 4th over 4 minus x cubed over 3, but the 3 cancels that out. And I just caught a little mistake here. This is actually plus, right? Go back to the original. Don't want to make that mistake there. All right. So we're going to evaluate that from -3, not -30, 3 to 0. And so we're going to plug in 0, and we get 0 plus 0, which is 0. Going to plug in -3, that's minus. Okay, FTC1 says evaluate the right and then subtract the evaluation from the left. And we get 81 fourths plus -27. So minus 27. 27 is 108 fourths. So this is going to be 81 minus 108. 81 minus 108 is -27 fourths. And then take out the minus, or minus negative is going to be positive. All right, 27 fourths, there you have it. Is that close to 6, hopefully? 4 times 6 is 24, so it's actually a little bit bigger than 6, but there it is exactly. All right, a couple more quick ones here. We want to find f prime here. So we've got an integral function, and we want to find the derivative of an integral, and x is one of our bounds there. So all that matters is that this is a constant, and we can use FTC2. And so this is simply e to the sine of x, 3x, because it's 3 there, plus sine of e to the 3x. All right, this would probably be a kind of a bare, well, we don't really even have the ability to integrate that, not with our tools. So, but we can take the derivative of the integral, and there it is. Now, if one of our bounds here, we got a constant. It doesn't have to be 0. It could be any constant. But this is not just plain old x. Well, we're going to do something similar. We're going to take and drop in, instead of x like we did here, we're going to drop in 3x squared. So we have 1 minus cosine of 3 times 3x squared, which would be 9x squared, to the 3x squared power. However, one more thing, we've got to use the chain rule. As a result of the chain rule, we've got to multiply by the derivative of this, which is 6x. And there it is. All right, let's talk about a little 1D movement here. We got a velocity function here, and we want to find the displacement for the first 10 seconds. Well, we know that the integral of velocity, or the antiderivative of velocity, is position. So using the integral from 0 to 10, we get displacement. So the displacement is the integral from 0 to 10 of 4t minus 8 dt. And that's going to be t squared. Divide that by 2, we get 2 minus 8t. Going to evaluate that from 0 to 10. And if we need be, we can use our calculator here, but I think we can get it. We get plug in 10, we get 200 minus 80. And then plug in 0, we get 0. All right. And, oh, lost my AT. And so this is 120. Oh, it didn't give us any units here. So 120. Guess probably feet, but didn't put that in the problem. So watch out for that. And lastly, total distance. Remember, that's different. So total distance, we have to find out when did this stop. Well, if we think about a little number line for velocity here, 4t minus 8 is, here's 0 to 10. At 2 seconds, so 0, velocity is 0, okay? It's negative, meaning it's moving to the left before that. And if you plug in numbers like times like 3, 4, 5, you're going to get a positive number, right? So it's moving right. Okay, so this is left, and this is moving right. Okay, so it changed directions. So what we're going to have to do is we're going to have to find the absolute value of the integral here. And so the integral from 0 to 10 of the absolute value of v of t, which is the integral from 0 to 2 of v of t, the absolute value of that, because it's negative, okay, plus the integral from 2 to 10 v of t, which is going to be positive because we're moving right. Okay, so if we take 2t squared minus 8t, we're going to find that from 0 to 2. And then 2t squared minus 8t from 2 to 10. Okay? Actually, these absolute values could be out here. You know, it's the absolute value of this. Sometimes we write it out like that. Let's get rid of that. That's the idea. Okay? So we get, plug in 2 here, you get 2 times 4 minus 16, but we're going to take the absolute value of that. Here, plug in 10, we're going to get, and then minus 0, right? So that's going to be 0, but watch out. Gotta remember both. So plug in 10, we get 2 times 100, which is 200, minus 80, that looks familiar, minus plug in 2, and that's where we get, again, 2 times 4, minus 16. So we get 8 for the first part there, and the absolute value of 120. And this is minus -8. Okay, because it went from -8 to 20 is where it went in position. And so, and this one here got absolute value. Okay, so we went 8 feet, and then we went from the -8 position to 120. All right, and so this is 128, and so we have 136. Again, probably feet, but we didn't really state that. But I'll throw it in there, pretend like it is. All right, so that's the idea. We actually went 136 feet, even though the displacement from the beginning to end was only 120. All right, there you have it. So for our little final test, we will cover Chapter 5 stuff with areas and volumes and differential equations, and then we'll have a few problems like these guys, okay, from earlier on in the unit or the semester. All right, guys, study hard. Let me know where you got questions. We'll see you on the test day.